Hello, we're starting the stream.
Hello.
Um, so we both have a little bit of things to update on that we worked on off stream, and then we're gonna work through another chapter of that tutorial again today of AI for beginners. So we're gonna go through waypoints and graphs today. We're just gonna watch our way through that. It says it takes an hour 25 minutes. 2x speed, but also pausing. Yeah, it's hard to say. Oh, we stop it right at the A star algorithm. That's pretty cool. And then we move into a full lesson on the A star. Alright, whatever. Anyways.
This is my new pixel art game. It's done.
You can buy it on itch right now.
Yeah, it's not donation based. You have to. You have to pay 40.
It's $1 per pixel.
Plus tax.
It's the industry standard right now. Just the going rate. Yeah, do you want to recap your thing first? Because I have your screen up now because of that bit.
Yeah, here. This is we spent a lot of time making our movement script, and it was all based on a sphere. So I just set up like a first-person thing that works with the movement scripts that we had. So it works with custom gravity, and it turns like a first-person camera still, because like the body is separated from the ball. The ball just determines its position. So yeah. I have my ricochet laser.
You can set that to go like crazy far, can't you?
Yeah.
You have it limited to like X amount of bounces.
I just reset everything to put this little gun in.
Yeah, it looks cool in that style.
Bring the length up. 1,000. 32 bounces. Oh, and bring it up.
Oh, there you go.
So you can see like perfectly reflects off the surfaces that it's gonna hit.
Now, can you make it like only reflect on certain things, maybe, or would that be hard?
No, I can already.
Oh, nice.
Right now, the gun is inside my body, and the raycast ignores my body already.
Oh, there you go. Perfect. So I was saying that we could set up like a mirror puzzle with that.
Yeah, I was thinking of some sort of like jam game where we take this thing and just try and make a level of like some sort of shooter puzzle, you know? Like, if I had free look here, I could turn and see exactly where it's gonna go.
We also could, in fact, couldn't you use that to move an object along that path so it does like a really realistic, fun-looking, like ricochet thing?
That was something that I wanted to try today, and then I realized that it's a lot harder than one day, I think.
Wait, because that sounds like a big task for sure. You might want to look into DoTween for that. Do you know about that? DoTween is a plugin that's just for like moving things between 2 points, essentially.
Oh, okay.
And it just makes that whole process a lot cleaner.
Cool. I also made
Mix and Jam uses that
texture.
a lot. Oh, we should use that for the hit scan tank.
Oh yeah. Made an A sprite pretty quickly.
Yeah, send that to me at some point. I wanna get that working as the laser from the tank. That would be awesome.
But yeah, I also, just to show, in the last like 2 hours, I guess, I've been messing with something called Retro Suite, which is just on GitHub, and it has 3 or 4 effects, I guess. It lets you posterize the camera texture, so you can choose how many colors of each R, G, and B can exist. And if you do it up like 32, you get this cool effect where every edge looks like it's rounded off when you put like a circular light on it.
Yeah, it makes it look like a pillowed room, you know, like one of those, like, the insane asylum rooms.
Yeah. But it also has a dither where you choose like the dither pattern, you like import it, and then it applies it to things that are under a certain light level. So you could choose to just do it for like the dark bits.
That's pretty sick.
So like right now there's dithering in the all this dark blue, but like it's almost impossible to see.
I got like a. Can you put it back so that it showed up like really well on the light? Because I can't really see it on the stream much, like what the dither looks like. Oh yeah.
That's with it turned all the way up. You do something like that.
That's pretty cool having it have like the circles. It creates like that rounded thresholdy kind of look.
Yeah. And then, yeah, I was just messing with the Binding of Isaac thing.
What?
Did you ever notice that, or did you ever see that in Binding of Isaac? How they would do that?
No, what do you mean?
Like, they would have like retrovision, where it would like slide in, like their transition between levels is like sliding from low resolution to high resolution.
Oh, okay.
In this exact like style. If these were linked, I should make them linked. I'll do that. 512 by 512. Now I just need some like animations for the gun. I think I just need to do like one, like maybe 2 bones. Did you show the debris yet?
I'll show it in a second. Yeah, sorry, hold on.
No, 3 years before.
Sorry, the guys all got here, so we're just talking for a little bit.
Oh,
I know the Van Rollers. Yeah.
well, we don't have to go the full hour if you don't want.
So
We'll see. I don't know. It seems like it might be shorter anyways. Yeah, so I'll show the debris thing a little bit. What I worked on today was making it so that objects are like breakable. So essentially, like this barrel, if I walk into it, it just kind of pops, you know. So there's no like actual damage to it yet. It just pops when you touch it, and the same thing with the bench. And you'll see also the pieces kind of despawn after a set amount of time. I want to make it so that the individual pieces despawn at like a different rate. It looks a little more natural, but we'll see. And then the bench too, just kind of like explodes.
Your guys' colors on your screens are way different.
Oh yeah, well this is my screen. It's the same screen. It's just the difference between my 2 monitors. And you could also just plow through a bunch of shit like this, which is really satisfying. Right now it's only. I don't know, Connor. When are you coming down?
I don't really have a date, but I could come down whenever, really.
He says he's not really sure, just like whenever lines up. He just was planning on in general.
Come
Yeah.
over for Friendsgiving.
Oh yeah, Friendsgiving could be a good reason. That's a little far off still, alright?
Yeah, but it's enough
Yeah,
time
I'll
to
probably
plan.
be around there before then.
Yeah, he's thinking before then.
Oh, good. I'm like,
But yeah, and you
if
could
it's
see a lot of
easy,
weirdness with
you
how
don't
she
have to do much
rotates.
then. You just touch it or what?
What?
You just touch it and it breaks?
Yeah, that's just because I just wanted to get the behavior of like having something break, and then later I'll make the logic of like why it breaks. You know what I mean?
Yeah.
I just wanted to first get that like the how down. So right now benches and barrels just explode when you touch them. But eventually, you know, everything will be breakable like this, and it'll only break when you like hit it or
A
deal
certain
damage
level
to
of,
it
like,
or something.
Power that you hit it.
I had the idea of like, well, it's not my idea. I think Deus Ex did this, and I think GoldenEye did this, where like when you damage an object, its texture gets darkened a little bit, so it like
where you can tell it's damaged.
yeah, and then once it's like really dark, then so it'll take like 3 hits where it gets like darker, 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 and then it explodes. So I kind of like that system. I'd like to implement that, and I think I know how to do it, so
How
it
did
shouldn't
you
be
get
too
this
difficult.
Mickey key thing? Did you make this too?
I had my dad cut that out at his work.
Oh, what the fuck? I don't
What are
remember
these
this
keys
is
do?
heavy as fuck.
But yeah, that's what I worked on that. So I'm gonna AFK for a second.
Did it come with this little...
Okay, we're good now.
Cool.
Sorry about that.
No big deal.
But yeah, I mean, I think I explained it on the stream pretty good. I think I covered what I worked on. Oh, I also actually I do want to show this too. This is funny. On top of that, it also, because I feel like I'm gonna do this for like everything now because it's just too fun. I set it up so that the tank will also shoot these explosive barrels at me. And they shatter when they smack me in the head. Just pretty good. I like this a lot. The only problem with this is that if, because the shards will like kind of protect me over time, eventually it just makes a gigantic pile of barrels over me. Because the barrels that don't explode, they don't despawn, they just stay there. So they just keep stacking up over and over and over. Until eventually the game just crashes because there's too much shit happening. But I mean, I just need to set it up so that any projectile... Because what I have the die script, I think. I have that set on the cannonball. And I feel like maybe it should be set on the cannon itself, just telling the whatever ammo it shoots should automatically despawn like that. But who knows, whatever. But yeah, that's the gist of it. I had a lot of fun modeling the broken versions of shit though. I feel like that could be a prop jam of itself. Like just make a shatter jam where we just break a bunch of our old props. And it's pretty easy to do and it looks good. I just used a boolean and just like skewered a box to look all pointy. But okay, yeah. I think we're good then, yeah?
Yeah.
Okay, so let's start on waypoints. I'll update my stream so you could hear it. You hear it? Okay, so we got waypoints, following a circuit, graph theory, and then A star for pathfinding. So I'm not. I guess I understand what a waypoint is, and I have a general understanding of A star. I don't remember off the top of my head, but I took we spent a while on it in my AI course, so I'm sure that'll come back to me. But following a circuit and graph theory, I'm not really sure what that is.
Following a circuit probably just means going in a circle. Or like following a path in a loop.
Oh, maybe, okay.
Like Luigi circuit.
That's probably the reference they were making.
But
In this
after
lecture,
this,
we
the
will
whole
start
thing
looking at
is
one of-
called A-star algorithm.
Yes, that's going to be a whole lesson of its own. I'm glad it's important, though. It makes me feel good that course wasn't like a waste of time.
The most fundamental AI techniques used in navigation, waypoints. Waypoints are simply positions on a map that when navigated in sequence produce a path. It's the same system used in a car GPS that gives you instructions on where to drive. Waypoints are an easy system to implement in an NPC as it makes them look more intelligent than they are, and by providing them with a safe set of locations on a map to move between, they can also avoid obstacles. We've already created an NPC that can move and follow a goal location. Updating this to a waypoint system is straightforward. In this video, we're going to put together a waypoint system and have these tanks drive
So wait,
around
real
for
quick,
fun.
just to be sure, we're just watching, right?
Yeah, I don't plan on...
Okay.
You could take my screen off if you want. I'm not actually going to be doing anything.
Okay, I just want to be sure. I guess I could do play us out. Can you? Yeah, and then I just hide your screen. Yeah, because then it's just my screen. I hope there's not any issues with that. Can you talk? It'll pick you up still?
Does it pick me up?
Yeah, I think so.
guess, okay, cool.
Yeah, I guess I'll just do this. It'll just be my screen. There's no need for special shit on this one.
One to the other in a circuit. To begin with, you need the starter resource that's attached to this lecture. So download that, open up a new Unity project and bring those resources in. Inside of it, you're going to find a scene called Tank
So we gotta
Racing,
model
and
a
if you open
tree.
up that scene, you'll get something like this. So we have a ground, which is made of a cube that is stretched out with a texture on it. There's 4 different coloured tanks, and there's a palm tree. The palm tree we will use for our waypoints. Essentially, a waypoint only needs to be a 3D position, or 2D if you're on a 2D map, that's somewhere in your game environment. Usually when I'm putting waypoints in for, say, a racing track...
Oh,
or
I'll use traffic
a
cones
game
for this.
map, then I just use the sphere or a cube in Unity, just so I can see where it is, and then later on you can remove its renderer and make sure, of course, if you've got waypoints that you do take off any colliders, because they're not really in the environment, they're just showing us the positions where our AI controlled characters should go between. But in this case, I'm using a palm tree so we can actually see it, and in this kind of desert scene, it kind of makes sense, I guess. So with your palm tree, what you need to do is to Control D to duplicate it, then hit your W key, and possibly in a top-down view, just move that palm tree, try and keep it on the plane, but just move it, and what we're going to do is just make a bit of a circuit with it. Control D again, grab the duplicate, and then Control D. Make yourself just a bit of a circular thing that your tank can go around. Okay, so this tank's going to go around these and use it kind of like a little bit of a racing track, and these are the flag points for it. All right, so now let's actually write some code to achieve this. So go create C# down in your assets, and we're going to call this follow waypoint. So follow WP, and then open that up. First of all, your script needs to know about the waypoints themselves, and we're going to put those into an array of game objects. So create a public game object array for your waypoints. Then we also need an integer to keep track of which waypoint we're on. So we'll call that current waypoint, and we will set that to a value of 0, because your array index always starts at 0. So that very first tree will be the starting point. Okay, now we have to move our tank around, and therefore, while we're up here, let's just create a public float for speed. And we will set that to 10.0f, and of course you can change that however you like. All right, we don't need a start at this point, but down in update, we're going to basically loop through all these waypoints, but we don't want to go to the next waypoint until we've actually reached the next waypoint. Does that make sense? Okay, so we start at waypoint 0, and then we test if we're close enough to that waypoint, and then we go to the next waypoint. Now, do you remember how we test to find out if our character is actually near its goal location? Because this is what we need to do for each waypoint. So we have to use a distance.
I wonder if we're gonna have to like
If
manually set the order or
So
something.
we'll use
Like, do we
maps
click and
library
drag
and
the
running our own
waypoints
and we're going to find the distance between this
into
dot
the
transform
engine,
dot position, so that's going to
like
be
in
10,
engine? I mean,
and the
or in
waypoint's
editor rather.
current waypoint. So So this is the first waypoint
I don't
when we
know.
first come in here.
We'll
Dot
do, like-
transform.
Because it's a public array. I guess you could just fill it with
And
shit.
then we need to say, well, when are we close
Yeah.
enough to that particular waypoint? So let's say
Probably
if it's
is.
less than 3, we will consider that we've actually reached that waypoint. And when we do, we're going to update what current waypoint is. Current
This all
waypoint
makes sense. So this is
is
very
plus,
much
so then
playing
current
on
waypoint will be 1,
what we've
and
done
therefore we
before.
start heading towards that. Now, at
Yeah.
some point, our waypoints are going to run out. Okay, so say we've got 10 waypoints. At some point, current waypoint is going to be an index value of 10 or greater, which won't exist inside of this array. Because if you've got 10 waypoints, then you only have indexes of 0 to 9. Now, when that happens, we need to actually switch our current waypoint back to the first one. So if current waypoint is greater than or equal to our waypoints dot length, then we're going to go current waypoint equals 0. And we're also going to spell it correctly. Okay. So there's our current waypoint. So now we've taken care of going to the next waypoint and also going back to the 0 waypoint if we reach the end. The next thing we really need to be doing is actually pushing our tank forward. So we're going to go this.transform.lookat. And you remember what lookat does? It's going to turn your character to look at another location. So in this case, we want to look at the next waypoint or look at the waypoint we're going towards. So waypoints.
Should we have been using that for the tank?
I think we had a problem with it.
Did we use look at? Okay. I
Maybe
didn't.
not.
I didn't remember trying that one. That would be nice.
Current waypoint dot transform, and then this dot transform dot translate 0 0. So nothing in the x and the y directions, but we want to go along the z at speed multiplied by time dot delta time because we're inside the update. All right, so save that. Go back into Unity and we need to put this onto a tank. So we're just going to start with one tank. So select your green tank or whichever one you want. Drag and drop that follow waypoint script onto there. Okay, we now have our waypoints array at the top here that we can put all of these palm trees in. Now you can put them in one by one or you can select the whole lot of them. If you created them in a circuit in the order of your circuit, then it's going to be much easier just to drag and drop the whole lot in and then they'll end up in the right order in the waypoints array. So just go up to the top and click on the little lock, which will lock this inspector view. Then over in the hierarchy, you can select the first palm tree, shift select the last palm tree, and just drag and drop those onto waypoints, and that will populate that whole array in the correct order. Remember, we're going from one waypoint to the other, so if you change these ordering around, that will be the way that the tank will go. Okay, so let's just remember to unlock our inspector view.
Do you know why she does that
Yeah, so
locking
let's
shit?
play, and we will see that our tank
Well, okay.
goes off.
Why did she
again.
lock the inspector view and then drag it in and then unlock it?
Probably so that it doesn't switch to them when she selects it.
Oh,
If I had to
maybe.
guess. Probably.
Oh, I guess that makes sense, actually. Yeah. Okay. Okay.
Around the waypoints.
Damn,
Okay,
that's
so
a
with our
wrap.
current
That's
setup,
like
we're
the whole
gonna
thing
look at,
already.
which is making our tank snap around to look at the new waypoints. Now, that's quite an unnatural looking way for a character to move.
Oh,
We
that's
want it to
probably
sort of
why we
turn
didn't use
more
look at.
slowly and more naturally towards the next waypoint. And we've
Oh,
already
yeah.
had a look at how to do this by only turning a fraction of the angle between each direction that we're facing towards our waypoint
Oh,
or our
never
goal
mind.
location. Now, let me show you another way to do this, which is essentially doing it exactly the same way, but with some different methods. And for that, we're going to replace our look at. Okay, so I'm just going to comment that out so that you can remember what we're trying to achieve here. And instead, we're going to use the Unity quaternion system. So let's begin with creating a quaternion. So a quaternion stores a rotation. So quaternion look at waypoint, and that's going to equal quaternion dot look rotation waypoints current waypoint dot transform dot position minus this dot transform dot position. Okay, so that might seem familiar of getting your goal location minus the position of your character if you remember back to developing the vectors that we did where we were finding the direction vector from your location to the goal. So this is exactly the same thing. You're giving your quaternion look at a vector which is going to use as a rotation. So that gives you what you need to rotate through to get from your current rotation of your tank to facing in the right direction. Though we're only going to use a little proportion of this quaternion. The transform or this dot transform dot rotation is actually stored as a quaternion. So instead of setting it to look at a waypoint, which we could, what we're going to do is actually perform what's called a slurp. And slurp is spelt like you would expect, which is a spherical interpolation of the actual angle or the rotation that you're going through. And it basically means just turning a little bit through the whole angle. So transform dot rotation look at waypoint, and then we're going to put our time.delta time in here, which is the amount of rotation that you want to do through that entire angle. Let me just put this in front of here to be consistent since I'm using it throughout. Now, just like the speed here that you can set as a variable for how much speed you want, you can also set how much rotation you want. So let's put in our rot speed here and multiply that. And then up the top, we'll create a public float for rot speed. And let's set that also to 10. 10's always a good round number to start testing things with. All right, so we've got that. Let's now save it and have a look at the effect. Okay, so we will press play, and what you're going to find is your tank is going to turn quite smoothly around instead of snapping. So what do you think is going to happen if we go back to our tank and now we change our rotational speed down to, say, 5? Press play. Okay, and off goes the tank. And I don't know if you can tell a lot there, but it's taking longer to go through the entire turn. Let's turn that down even more to 1, and you should start to really notice it. It will start taking its time turning, which means you're going to get a much sort of smoother curve that goes through all of these.
That's a lot
arches. You can
better,
see
yeah.
how he's starting to wiggle along that path rather than taking the corners tightly as before. Okay, now what happens if we change the rotational speed down to 0.5 and we have another go? Let's press play. Okay, right, we have a situation where the tank is circling the waypoint. Let me just focus in on that for you. Now, what's happening here? Well, you've seen this happening before. We've had it with other characters that won't actually ever get to their goal location. So what's happening in this instance is that the tank is trying to turn towards the tree, but its turning circle isn't tight enough. So it's never, ever going to get within a distance of 3 of the tree in order for it to then switch over to the next waypoint. So you've either got to go back into your code and make your distance threshold here of where you reach a waypoint much larger. Okay, so if we set this to, say, 10, I think that should be okay for such a lazy turning vehicle. Let's see if we can get within 10 of that. Okay, so now it's considered to have been within 10. Same for that one there. But what you can also tell is that it's not very accurate, okay, because you're letting him have a lot of leeway as to whether he's reached a waypoint or not. So I guess it's up to the effect that you actually want. If you want them to sort of have quite a large turning circle, then you'll have to give them a little bit more leeway in how they get with their accuracy to those actual palm trees. But I'm going to set that back down to 3. Save that in the code.
I feel like I
and I'll
prefer
reset
that
the
having like the
tank's
really
rotation back
wide
to,
kind of
let's say,
thing.
5, so that we know now that we're going to hit these waypoints.
Yeah,
But just know that if you ever get your tank or car or whatever, you've got...
Especially if you have like a
waypoint
bunch of
just going
them,
round and round.
and
The
you have
waypoint
them all
is
of different
because of your
speeds and different
up the
rotation
waypoint
speeds.
because it's not able to turn
That would make
tight
it look a
enough
lot more
to reach that
natural.
particular distance that you're wanting it to. Right, now, I'm sure you're ready to put your script onto each of the tanks and have them race around the track. So get hold of your follow waypoint script and start putting it on each of your tanks. And don't forget to populate each of those waypoint arrays with all of the palm trees. So when we press play, off they go. Now, we don't have any physics elements on these at all, so they're just going to be on top of each other, which really makes it quite a dull kind of simulation. So what we're going to do in the next video is actually come back and start adding some physics elements to our tanks.
Oh. Interesting. See, 'cause I remember when I was learning the AI stuff in Unreal, and I was trying to make that city street thing, that was a big problem of the fact that the guys walking around would always overlap with each other, and I could never get them to like avoid each other or collide with each other or anything. So I wonder if we could like... I wonder if you could just do like a nav mesh and then make it like an element that's like, this is not a navigatable area tied to the character that just moves around, so the other ones just avoid it. That might be kind of a smart way to do that. But she's probably just going to put like colliders on there, I guess. We'll see.
In this lecture, we will start looking at one of the most fundamental AI techniques used in navigation.
Wait, what?
Same one.
How did that happen? What the fuck? Did I just click play again?
I guess so.
Oh, it updates the time.
Oh, I didn't notice.
I never do
So
that.
far
That's
we've
pretty
created
cool,
a waypoint
actually.
system around these palm trees for the tanks. But when we press play, it's pretty lackluster the way that they move around because there's no physics on them. So they're just going to clump together and go around the track. They're not going to hit each other or get each other off course, and they're all going at the same speed. So, you know, that's pretty boring. Once you start adding physics into a system, you basically kind of lose a little bit of control of what's going on. and therefore you need to kind of consider all the things that could go wrong when the physics happens and be able to correct them. So let's have a look at one technique that we can use when the physics added to this kind of waypoint system causes a little bit of havoc. First of all, let's select all of our tanks. So if you just shift select all of the tanks, we're going to add a box collider to them. And you can see the box collider sitting on those. And if I just get in a little closer here, can't quite see it in this view yet, but there is a box collider inside, and when they get a little bit bigger you'll be able to see it. And also at the same time, let's just add a rigid body because we need that for the physics system to consider these tanks as solid objects. Now with your box collider you can modify it, and because you've got exactly the same model, which is the tank, and you can see each of the colliders on there, you can actually just resize them all at the same time. So we need to make it a bit taller, so let's just increase the height of them. We also need to make them a bit longer in the Z direction, and then we also need to move it forward a little bit in the Z direction as well, and also move it up. Make sure that you move it up to a point that you can see it above the ground here, otherwise your tank is going to fall through the ground when you press play. Let's just move it around. So there's a line here, I've just brought that up above there, and now that's a better view there. You need to make it a bit wider in the X, so let's change the X size to make the tank a little bit wider. And then just have a look at what we've ended up with. Not too bad. There's a bit of room in front, but that's okay now for our purposes. Right, so they've all got a collider on them. The rigid body, we're going to freeze the rotation. So go down to constraints, and in the freeze rotation, freeze the X and the Z, so the tank doesn't actually flip over. It's only going to go around its Y axis, which is the up axis. Okay, we're ready to now play and have a look what happens. So press play, and initially some tanks are thrown off course, but then they come back. You would have seen those two there, the green and the yellow. Let's have another look. They have to hit that waypoint in order to come back because they have to go to each waypoint in succession. Let's make this a little bit more interesting by changing the values on each tank for the speed and the rotation. So let's make the yellow tank's rotation 15 and its speed 5. So we'll actually slow it down. Let's make the blue tank go really fast, so 50, and we'll give it a rotation of 8. The red tank can go at 15. We'll leave that at 10. And the green tank, let's make that go at 40 with a rotation of 3. All right, so let's now, just to make it really interesting, shift select all of your tanks and Control D to make a duplicate lot of them. Then hit the W key and go over in the scene and just move those tanks out and do it again like that. And, oh, let's do it again. So we've got some more. Lots of tanks. All right, so now let's have a go and see what it does to our situation. Okay, so because of the initial physics and because of the settings on the car, the different settings, some of them are okay. The green cars, well, they've got a really bad turning circle, so they're getting stuck a fair bit. Now, this green car over here, if we have a look, has obviously made it all the way around the track until it got to this tree here, and then it got knocked off of its course and has now gone around the tree. And you might have seen just then there was another green car that must have got knocked back onto course by another car and ended up coming around because now it is at this tree here, because they have to go around in succession in order for them to actually progress. So this is a bit of an issue if cars can get stuck at a waypoint, especially in a race.
Blue cars
so
are OP.
if you miss a waypoint, and I said this previously, then you want to sort of get back on the track without trying to hit an actual single location. Right, so in order to do
They're
that,
causing all the
you
problems.
need to create an object that's going to follow the track around and then have your tank follow that object. So you want it like a super accurate progress tracker, that's what we're going to call it, that stays on the track, and then the tanks actually follow it instead.
Wait,
So
what?
go into your script, and what we're going to do is create a new game object. So at the top, we're going to declare it, so game object, and we'll call it our tracker. And then we'll create this tracker down in the start. So the tracker is going to equal game object dot create primitive. Now I'm creating a primitive object so that you can actually see where the tracker is in Unity. Of course, you don't need to see this position. It's just a point that's going to be moving around the map. But so that you can visualize it, we will make it, I guess, it's kind of solid object.
I'm not
So
super
we're gonna
clear on what
create
she's
the
doing,
primitive
but I guess I'll
of
just give it a
cylinder.
shot.
So
I'll give
just
it.
select that
I'll
from the
wait.
drop-down list if you're in Visual Studio. And then we want to destroy immediately the collider that's on it. So tracker dot get component collider. And make sure that that's a capital G for game object create primitive. Right, the next thing we're going to do is set its position and rotation. So tracker dot transform dot position equals our tank. So this dot transform dot position, and the rotation tracker dot transform dot rotation equals this dot transform dot rotation. Okay, now the tracker, we want to move around the track using the original method that we had for moving the tank. So let's create void progress tracker. And this method will actually replicate what we had previously. So first of all, it's going to test the distance of the tracker to the waypoint. And we've already got that code sitting down here in the update. So I'm just going to copy that as well as the length of waypoint. So let's copy that out of there and put it down there. And then what we're going to do is actually perform a look at again for it so that it is perfectly going towards the tree. So that would be tracker.transform.lookat. And we're going to look at the waypoints of the current waypoint.
So she's making a thing that follows the waypoints like perfectly, and then the car follows that instead of them following the waypoints directly.
Translate 0.
And that's to prevent it from getting stuck on shit, I guess.
This speed
Yeah, I
here,
think.
you can
I mean, it
modify
makes
that based on how
sense
fast
to
you
have
want
like
the
a
tracker to go around the track. But what you've got to make sure
perfect
that you do
version
is
to
your
like
tank
refer
and your tracker
back
can't
to
get too
if
far away
something
from each other.
isn't
Otherwise,
working.
the tank, which is going
Yeah.
to be following the tracker,
I assume
not the waypoints,
it'll,
is going
like-
to start skipping off the track and taking shortcuts, which is something that
Like
you
slide
definitely
in
do not
between
want.
the two.
Alright, so with that code, we're going to go down into our update, and let's just get rid of this because we're not going to be using that again. And we'll put in here progress tracker. And we'll also just comment out these lines of code just for now so that our tank doesn't go anywhere. It's our progress tracker that's going to be moving.
Can I get
And
credit
because
for
it is
saying
the
this?
progress tracker that's
I've
moving,
been saying
when we test
this.
for the distance in order to go to the next
Oh,
one,
yeah,
it's
the
actually
GTA
tracker that we
controller
test the
thing?
distance for.
Yeah.
So back up in progress tracker, make sure that you change that.
That is
to
very true.
tracker.transform.position
deserved.
is less than 3. Otherwise, it's not going to continue around the track. Right, so save it. Let's go back into Unity.
I even
Now, once you're
have
in
a-
there,
I
you can
have
see
a
that I've already
script
done this.
called
I've just
Tracker.
left one green tank active. So go through and select all of these other tanks that you've got in the scene and just untick their box that's right at the top of the inspector, which will just turn them off
I just
for now because
didn't
they've all
do
got
it
exactly the
good
same
enough.
code on them. And let's press play. We'll see that
Already
the
so
cylinder
much
gets
better.
created and off goes our cylinder on its merry way around the track. Now, because it's turning and perfectly looking at the palm tree or the next waypoint, it's going to always hit it. And it's still got a distance of 3. Because it is perfectly turning towards the position of the palm tree, you could probably turn
Yeah,
that
so if it
down
follows
a
it
little bit
just,
more
like,
so you've got even better
at a
accuracy.
at a
Okay, so you've got our
distance, it'll
tracker.
just, like,
Now we want to get our
keep
tank
swinging
to
behind
follow
it.
that tracker instead.
And it'll look like natural.
Okay, so back into our code, and we're now not even looking at anything, so we can get rid of that line that we commented out much earlier. Our Quaternion look at waypoint is actually now not looking at a waypoint, it's going to look at the tracker, so you want to change this to tracker here. Then we can do our slurp of our tank's rotation, which is fine, and then we can push our tank forward by the speed. Okay, so that is fine as well. So let's just save that and go back to Unity and have another little look. We'll create our cylinder. It's going to move along. And you can see that the tank is now circling our cylinder. Why is it doing that? Well, it's moving much faster than the cylinder is. So therefore, we have to make our cylinder move faster than the tank. Back into our code. So the progress tracker, we've now learnt, needs to go at least as fast as the tank itself. So let's put speed multiplied by time dot delta time in here. And let's just say speed, let's just increase it a little bit so it's in front. Speed plus, say, 2, like that. And because it's not actually turning, it should stay ahead quite nicely of the tank. Save it. Let's go back in and play again and have a look what we're getting. So off it goes. Now you can see that the tank is following it nicely.
Yeah.
That's pretty
And
sick.
It's taking a lot of shortcuts because of the actual distance between them. So you could change that distance so that is a little bit shorter. Now what happens if your cylinder ends up going too fast for your tank? So if the tank gets knocked out of the way by another vehicle and it ends up way away from it, it could actually, instead of getting back on the track, take a shortcut straight across the actual track. Let's go back in here and let's increase our speed. Let's make it, say, 20 faster than the tank, and go back and run that and have a look at the result of your tank going around these trees. Okay, so now you can see that the tank is taking massive shortcuts around the trees because this tracker is just getting so much further ahead. So we actually want to reduce the tracker from getting too far ahead of the tank. Right, so back into the code. What we're going to do at the top is create another public float, and we will call it look ahead. And we're going to say, how far ahead of the tank will we actually let the tracker get? So let's say that it's 10. Let's say 10. which
That's
might
a smart way to
go-to
handle
value.
that.
And
I
then
was
down
thinking
the
of having an
tracker,
event
we're
for
not
like
going to
when
let
it
move
crashes
any
for some
further
reason. That's way
unless
smarter.
It is within 10 of the tank itself. So we'll do another distance test here. If vector3 dot distance between the tracker dot transform dot position and this dot
Tracker?
She typed tracker.
position, and an easy return out of that. So let's save it, go back, and we'll have a look at what we get when we press play. So the tracker you can see now, and you saw it at the beginning, let's just get closer into here and have a look, is it will stop and wait for the tank to catch up to it. And you saw that there. So it's never, no
That's
matter how
fucking
fast
cool.
you make your tracker, going to get beyond the tank. But you can adjust it to be even further away if you want to. So now that you've got that tracker on the code, it's now going to be on all of your other tanks. We can actually put these tanks back into action and press play. And now you won't get any tanks that will circle their waypoints because they're following these sort of perfect trackers. The last thing, of course, that you need to do now is just go back into your code and make sure that that cylinder doesn't show up in the scene. So in here, what we're going to do is put tracker dot get component mesh renderer dot enabled equals false, just to turn off that cylinder so that you can't see it. Save that. Let's go back into here and we will just move this around. So, top view of it. And press play.
I would think to make the really fast ones have like a
Now we
really
have
light
a
mass.
Very basic.
Like the really
set of
heavy ones
waypoints,
have a
circuit of
huge
waypoints,
mass. That could
and
make it a
some
little
different vehicles that go
interesting.
around there, including the physics.
Mhm.
There's a little bit of sliding going on, and some of the vehicles are being knocked out of place. But that's up to you to experiment with now. So you can change the rigid body settings, make it a heavier vehicle. So
That looks
when it
really
crashes,
fun,
they won't
though.
go Flying. You might even want to remove the other physics restrictions that we've got on freezing the rotation just to see how that will work. But what you've now got is a good way of creating AIs that go around the circuit in a more believable fashion than ones that sit there and circle around the waypoints.
I'm excited to play with that. That looks like a good time.
Yeah, that was very cool.
Especially if I like tie animations to it, so it's like an actually little running guy. We'll see how far I get with that.
Of AI without a brief background in graph theory. Almost all AI techniques used in games rely on programmers having an understanding of graphs. Graphs in this context refer to a collection of nodes and edges. Nodes are represented graphically as circles, and edges are the lines that connect them. A graph can be visualized as nodes representing locations and edges as paths connecting them. A graph can be undirected, which means that the paths between nodes can be traversed in both directions, or directed, in which case the paths are one way. Think of this as a difference between two-way streets and one-way streets. Nodes and edges can be drawn where nodes represent coordinates such as those on a flight plan, or as symbolic states where the physical location in the graph is meaningless. Both nodes and edges can have associated values. These values could be the distance between nodes, such as those representing distances in the flight plan, or the time it takes to complete an action, such as a node in the action plan. The ways in which graphs are useful in game AI will become evident as we progress through this course. If you think graphs look familiar, it's because they are. We've already made a graph of waypoints and had our NPC traverse between them.
What?
Graphs are so flexible that they can
Did we skip
it's
one?
The old version.
The fuck?
be used for a plethora of applications where you need to traverse from one
the same
state to
thing.
another, whether that be
Yeah,
a
so
real
it's
state
just the
or a
same
conceptual
thing.
state. In this example, a
different
graph is being used to define the
version.
locations in a tile-based game and the amount of effort to move from one tile to another. Values placed on the edges are generally referred to as utility values, whether they represent times, distances, effort, cost, or any other value an NPC might use to make a decision. Let's consider the situation where an NPC wants to move from tile C2 to A2. There are two possible paths. To decide which path to take, the NPC can add up all the utility values along each path. In this case, the utility values aren't about distance, they are about terrain difficulty. Adding up the values along each path reveals that the longer path over the bridge will be less effort. In order to work with a graph, there needs to be an efficient method of searching through the nodes. There are two basic high-level algorithms for searching through nodes. The first is called a breadth-first search. In a breadth-first search, the NPC marks its current location or node as 1. Then it numbers all adjacent nodes to that as 2. Then all the adjacent nodes to them as 3, etc., until the destination node has been reached. It then counts backwards in ones to the start to find a path to the goal. Breadth-first search examines all possible nodes in the graph to find the best path. But due to its thoroughness, it's time-consuming and not optimal. A depth-first search is much simpler and quicker, but less effective. Instead of finding the best path, it finds a path. Beginning at the NPC position, an adjacent node is found and numbered. Then an adjacent node to this is found and numbered. This continues until a dead end is reached, at which time we return to the last node where there was another direction to try and we head off in that direction. It's like the approach you might take to get out of a labyrinth. When the destination is found, the nodes are then counted backwards again to give the path. The most popular algorithm used to find paths in graphs that is used in games because of its efficiency in being able to find the shortest path is the A-star algorithm. It's a little more complex than the other two methods and works like this. First, all the nodes in the graph are numbered. We then create two lists, an open list and a closed list. These will keep track of the nodes that we've visited and processed. Each node is given 4 values that are used in calculating the path. First, they are given a heuristic value represented by h. The heuristic is the estimated cost of getting from an individual node to the destination. You can use any method you like for calculating that value. You might use a linear distance or count the number of rows and columns. The second value is movement cost, represented by a g. This value is essentially the utility in moving to the node from another node. This could be based on the actual distance from one node to another, or the cost of traversing a terrain type, like the tile example we looked at with the bridge. We then store a calculation that adds together the h and g values and call that f, and store the node's parent, which is the closest node along the path. Let's take a look at an example. We begin by placing the starting node, in this case 50, into the closed list, as this is the location we have visited. We then look for any neighbours that aren't blocked and aren't in the closed list, and add them to the open list. We then calculate the heuristic for each node in the open list. In this case, we will use the linear distance from the node to the destination. Then we work out our movement cost to go from the starting node to the neighbour. Again, we use a linear distance. Horizontal and vertical neighbours are a distance of 1 away, with diagonal neighbours a distance of 1.4. The cost of moving to those nodes becomes their g value. From that, f, which is h plus g, is calculated. Whilst we are doing this, all the neighbours are linked back to the current node, thus making the starting node their parent. With no more nodes to examine in the open list, we now get the node in the open list with the lowest f value. This becomes a new location to start searching the neighbours again. The new location node is added to the closed list as having been visited. Any neighbours not blocked, closed, or already on the open list are added to the open list. The h value is calculated for any new nodes in the open list. The g value is also calculated, but this time it is the cost of movement plus the previous cost of movement. So in this case, node 32 gets the g movement of 41 plus the cost of moving from 41 to 32, which is also 1. This gives a final g value of 2, and for 32 its f value will be 7. For any other neighbours of the current location still in the open list, in this case 40, a new g value is calculated. If the new g value is less than the current g value, the node's g value is changed and its parent is updated to the current location. In this example, a new g value coming from node 41 would be 1, the g value of 41, plus a horizontal movement cost of 1, thus resulting in a value of 2. 2 is not less than 40's current g value, and so the node remains unchanged. Any neighbour without a parent is assigned to the current location. And the process begins again by looking for the node with the smallest f value in the open list to visit next. The process ends when we are one node away from the end. At this point, we have a link of parents that lead all the way back to the start, which when reversed provide a path from the start location to the destination. Unity uses the A-star algorithm for pathfinding in its nav mesh. This construct provides a powerful way for us to program navigation and avoidance into our projects. When you think about it, graphs and their nodes and edges are really a very simple thing. As we progress further through the course, you're going to see them pop up all over the place, as they are a staple in artificial intelligence. While there are numerous algorithms to traverse graphs, when it comes to games, nothing beats A-star, and you'll find plenty of resources to support it.
Damn, that was a good one too.
Yeah, it was a weird ending.
It just came out of nowhere. But yeah, that was when we did A-star and breadth first and depth first, we did it with like trees. What do they call, like these kind of guys?
I can't see
Oh.
because you're, but I can imagine a tree.
Let me try something. I think, can I do this? What is it called? In browser Photoshop. Photopia. And then if I just paste my screenshot. New project. Hold on. Get the fuck. What is all. There it is, yeah. That's all I was trying to show you.
Oh, okay.
But yeah, it would be like, you know, trying to get to like a deep point down here, and it would do that same thing where it would calculate up getting to the root.
Mm-hmm.
Like, what is the most efficient path to that? Alright, we're getting ready to go full A-star.
Oh, there's a part 1 and 2.
Yeah, and then the next one is just all A-star. But it seems like a lot of the nitty-gritty is going to be done already, like by Unity. But not that we shouldn't pay attention to this or anything, but...
Yeah, we'll probably, or she'll probably end up showing how we use it.
Yeah, I wouldn't be surprised if she makes her own version of it and then implements, like, or you could just use the nav mesh and like tie it all together. We'll see though. I'm really glad I took the AI course though, because I would have been like very confused by that. feel like that helped me a
In
lot.
this lecture, we're going to look at creating a waypoint system that can be navigated with the A-star algorithm. To begin, download the resource file that comes with this lecture, and in it you'll find this scene with the tank. If you've done any of the other Unity provided tutorials, you'll have seen these models before, and I use them quite often because, well, they're nice to look at and they're convenient and easy, so we don't put our own map together. Of course, if you want to put your own map together, go for it, that's fine. Now, we've got a map, and we've also got a little tank. The tank will be our NPC character. What we're going to do is place some waypoints around the map, and then we're going to link them up with edges and put some buttons on the screen to give the tank orders of where to go to. The first thing we'll do is place some waypoints. The important thing to remember here is that there's no physics or collision detection that will be in this project, which means you have to place waypoints where the tank can move, so it'll be the paths. In the project, I've created a waypoint game object asset here. So this prefab, if I drag and drop it into the scene, you'll see that it automatically gives itself a number. And each time you add a waypoint, it will count up for you. So this is so that you can keep track of which waypoint is which one without having to click on it in the hierarchy each time. So let's just zoom out. I'm going to place some waypoints.
How'd you get the
around
text
this
to
map
like show up above
to
it
get
like
to
that? That's
the
nice.
helipad, which is down here, and one to get over here and to go around this building.
This is a
But you can place
text
them wherever you
mesh.
like. So I'll just go ahead and do that quickly. With all the waypoints in place, they will become the nodes in our graph. So we need to now determine where the edges are going to be, and the edges are the lines that connect the nodes and will tell us where the tank can travel between. As I said at the beginning, these waypoints are also going to specify where the tank can't travel, and that is that we don't want to
Yeah,
put
does the
any
order
paths
of the
through
waypoints even
geometry.
matter
So
now?
it's working as a collision avoidance system as well. And so you can put waypoints
I don't
like this
know.
through buildings if you want your NPCs to travel around in there and look like they're intelligent because then they're avoiding obstacles. So in this case, we can connect waypoint 1 with 2 and 2 with 3 and 1 with 3. Anywhere where there's a clear line of sight, we can join them. So we can't get from here over to number 7 at the back going that way. So we'll put lines here and here. And I might even put a one-way path that goes up to here so that the tank, if it is over here and wants to go back, has to go around this way. With all your paths planned out, you might like to write it down so that you've got a reference for when we go and put this information back into Unity. Now it's time to start creating some code, but just before we do, we need an object in the scene which is going to manage all the waypoints essentially. So in the hierarchy, right-click and create an empty, and we're going to call this object a WP manager. So this is our waypoint manager. On that, we'll put some code. So let's go over to the project and create a new C# script, and we'll also call that WP manager. It doesn't matter if they're not the same. I just like to keep it consistent. Now with that WP manager, I'm going to drag and drop it onto our empty game object. And then we'll open it up and start to edit it. Above the WP manager class, we're going to add in a little struct, and that's just there to help facilitate the data entry and storage of our graph. The graph is going to go all into another system, but we still need to be able to put the graph into the WP manager in some way. And the simplest way at the moment is just to make the inspector look good to facilitate this, essentially.
I don't really know what this is. But
Which bit?
is it just a separate class, I guess, within the script that's only thing is storing these objects?
Yeah. Basically.
Okay, I guess I just never really seen it with... I've never really used two separate classes in one script.
Yeah. It's just defining a type.
So you
in
could use
First
those
Blood.
things in a WP Manager then?
Yeah.
Okay.
So this is a link, and a link is going to be basically the edge. So it defines the nodes on either end of an edge, the direction of it, whether it's a unidirectional, which means that it goes in one way, or whether it's bi, which means that it travels in two directions. And that's stored down here in the direction thing. So there's only three things in here essentially. Next, we're going to define the waypoints, the links, and also make a graph from them. So at the top here, add this. So we have a game object array holding our waypoints. This will be all of those spheres that we've placed down on our map. Then we have an array of links, which we will also define, and this allows us to say this one connects to that one, and this one connects to that one, and whether you can travel in both directions or not. And if there's no link for waypoints, then they obviously aren't connected. Then with all that, we will create a new graph of type graph. Now, the graph code and the A-star algorithm has all been written for you, and I've provided that inside this graph folder in assets. If you have a look in there, you'll find three classes. There's one for graph, one for node, and one for edge, and they're all very elementary. So please do have a look through those, but I won't go into any detail of their inner workings, except to tell you that that uses the A-star algorithm. Back in the WP Manager code, we'll work in the start function to set everything up. So in here, just add this code. We're going to loop through the waypoints array, which is at the top, and this is the one we feed our waypoints to manually. If there are waypoints in that array, we're going to loop through each one and feed it into our graph that we've created up here. And so the graph code has an add node method, and you can feed the game objects through into there. So each node has to exist, each game object needs to be added into that graph before you can do anything with your links. After that, we're going to then do the same thing with the links and loop through those and use the graph.addEdge method to create an edge between one node and the other. Now, this add edge only does unidirectional edges, so one directional. If the edge we've defined is a bidirectional one, then I've got a little test in here just to check that you've made it bidirectional. And if it is, then it adds another edge and just swaps the two nodes around. All right, so that's all you need to construct the graph. And you can now put as many waypoints and edge definitions into these things via the inspector, and it will build it all for you. Now, one last thing that will be really nice is if we can see the edges, because we can already see the nodes on the map. But if we can see the edges, it will help us to debug the program. In the graph, it's got a debug draw method like that. If we put that in the update, then we can see the edges that we have created. All right, so save all that, and we'll go and fill up the inspector with our nodes and edges. On the WP Manager, you'll now find waypoints and links. So we've got 11 waypoints. I'll put 11 in here to open that up. And these are all the separate waypoints, and I want them to be in order. So that means I need to drag them in one by one. So I'll quickly do that. The next thing to fill out is the links. I've got 13 links, and that's the number of individual paths between each of your nodes. So I'll put 13 in there, which will expose all of the elements. So I'm now going to create these links one by one. The first link that I've got is the one between waypoint 1 over here and waypoint 2 down there. So I'll grab hold of waypoint 1 from the hierarchy and drag it into there, and waypoint 2 into there. Now, if you have a unidirectional link which only goes in one direction, then you want to put the starting node first and the second node first. With this set to uni, it would only let the tank go from in this direction. It couldn't go back again. So I'm going to set that to bi because I do want the tank to be able to go back and forward between those two. The next element that I'll put in just to show you what's going on with the link between 8 and 9. Remember I said I wanted to put it just in one direction. So I want it to go from 8, which will be our first one, to 9, which it will be the next one here, and then leave it at unidirectional instead of changing it, so it'll only go in one direction. All right, so I'll go through and do the rest of these, and it's probably easiest if you did have all this written down on a piece of paper like I've got, and then you can cross off each path as you've done it, which will make it a lot simpler. When you think you're done with all of your paths, you can press play, and then switch back into the scene view, and you'll be able to see those paths. So they're drawn out where you've created a link, and you can see them there. Now, if you zoom in a little bit closer, the line or the edge has a blue mark at the end of it. So that shows you the direction it's going in. In this case, you can see that there's a blue mark on both ends of that line. So that means you can travel back and forward along it. Now, our only unidirectional one at the moment, if I come around here, is this line here. And you can see there's, I hope you can see, it's quite small, isn't it? Let me move up. So there, it's got a bit of blue. And at the other end, it's got no blue, which means it's traveling in this direction in our unidirection. So if our tank ends up down here, the only way it will be able to get back to anywhere over here is to go around this shed or whatever it is. Okay, so now we have our waypoints. We just have to let our tank know about them. We'll create some driving code for the tank. So going to create C# script, and we'll call this follow path. And this code is based on the move local code that we've used before. So in here, we're going to add some code. I'll put it all in at once and then go through it.
Sorry, hold on a second. Okay.
With you. Okay, so here it is. Like before, we have a goal, but it's not exposed this time because we're not passing the goal through as something that the NPC can grab hold of. The goal will come from our A* algorithm. Next, we have the usual suspects. We've got our speed, we've got our accuracy, and we've got our rotational speed. So we need those values again. After that, we'll need a public exposed value for WP Manager because the WP Manager has hold of all of the waypoints and the graph information, and the NPC needs to know about that. So we'll pass that through to this code in the inspector. Next, I'm creating some local values, so a WPS here, which will grab hold of all the waypoints from the manager, and then we've got a game object representing the current node that we're trying to get to, and that, I guess, essentially is our goal at any particular time. After that, there's an int called current waypoint. Now, this is the index of the waypoint along the path that we're following. So if we're going along a path, and let's say there's 3 waypoints in it, then the first waypoint would be number 0, the next one will be number 1, and the next one will be number 2. Okay, so this is just to keep track how we've moved along the path that the
So now we're working on the actual
for
like
us. It
Pathfinder.
doesn't have anything to do with the waypoint's position in our waypoint array. So it's a completely different thing. Now after that, I've got graph declared as well. And these things, this WPS and graph, is just to make our code a little bit shorter later on. And you'll see why immediately, because in start is where I set them up.
I've never
If I
heard
didn't
of
have
a
these two
graph
things,
type.
we'd have to type this code in each time we want to
Me
grab
neither.
hold of something from the waypoint manager. So it's much easier just to assign it into these variables here where we can grab it. Next we need to set the current node, which is this game object up here, which does point to the physical node.
Well, is that a
sphere that's in our world.
is that a custom thing she
Yeah.
made?
Is set to 7 in this case because my tank
I'm looking it up.
is near 7. Actually, it's not near 7. It was near 7. It's near 1 now. My waypoints have renumbered. So let's just change that
Unity,
to 0
no,
because
not Unity
for waypoint
graphics.
1 in the array it would position at 0. So
Because she said she made a custom script just called graph, and that was
Oh,
what
she
was
did.
doing the the actual A-star algorithm. But
Oh, okay.
yeah, I think that's what that is.
Yeah.
So whatever waypoint your tank is near, that's what you want for your start. So it has some kind of a reference as to where it currently is and then how it's going to calculate how it moves through the A-star algorithm. All right, so that's the start. Now, after that, there's 2 functions that I'm going to come back to. Let's go down here. Now, in the late update, there is, first of all, an if statement asking us if the path length from our graph, so if graph.getPathLength is 0, which is essentially saying there is no path length, or the current waypoint index is equal to the path length. If you've got a path with 3 nodes in it and you're up to the 3rd node and your path length would then be 3 as well because it's got 3 things in it. If these 2 are the same, it means you're at the end. So if you've got an empty path or you're at the end of the path, then just return. You don't want to keep moving towards any goal because there is no goal. After that, we
Is the path something we like defined, or is that still something she hasn't done yet? Like, I guess, are we gonna pick like a goal and then it'll calculate the path after that? I was a little
Isn't that
confusing.
get path point? She keeps using get path point.
Yeah, but like, what is the path? I guess. Like, where do we set where it's trying to go?
I think that's from the A-star.
But we have to give it a goal still, right, for the A-star to work. Like, I'm just curious where we're...
We give it a. She gives it a an array of the points. So I think the idea is that it's whatever one is closest, it goes to that one first.
Okay.
set the current node to get the path point at the current waypoint value. So if we're moving along a path and we're up to, say, position number 3, then we say we want the 3rd node along this path, and it will give us the physical node that we need to be heading towards here. After that, we've got a very familiar looking little if statement, which is testing our accuracy. So if the distance between the tank, which is this transformed position, and the point at the current waypoint is less than our accuracy, then we're close enough to have been hitting our waypoint, just like the other algorithms we've already written. But in this case, we just increment the current count along our path, and this will allow us to calculate the next point and head off towards the next point. Next, we're doing another test to ensure that we haven't hit the end of the path, because this code up here might mean that we've hit the end of the path. Then we can move our tank forward, and we're moving the tank using the exact same code, which is this here, that you'll find that we developed in our move local script previously for moving and turning towards a point. So this is exactly the same, and the goal I'm just setting to be equal to the transform of the current sphere that is at position current waypoint in the path. So exactly the same code, same sort of movement. All we're doing is now following a path given to us by waypoints rather than us giving the agent a position to go to, because it's following something around on the map. Lastly, and because I'm running out of time in this 20-minute video, you need to add these 2 public functions, which I'll show you how to use in the next lecture. What they are public functions that can be run outside. So we will connect buttons on the screen up to these. And what they're doing is they're running the A-star algorithm. So this is the bit doing all of the work. If we want to go to the helipad, then the helipad is at waypoint 2. I've still got my old waypoint systems in here. Waypoint 2 is going to be waypoint 1 in the array, because remember, arrays start counting at 0. And the ruin is waypoint 7 for me, which would be 6 in the array there. So it takes the current node that you're at, the destination, and runs it through the A-star algorithm, which will give you the path that is now used down in your late update. After each one of the A stars you call, make sure you set your waypoint counter back to 0 so that you can start at
That's
point 0
cool.
on the map and then head through. Okay, so that's all of the code.
That's what was kind of
Save
missing
that,
for me was
and
the
I'll
like
catch up with you in
input.
the next lecture where we'll
Like what
Yeah.
was the input? That makes sense. So it's just set up having buttons that are just like destinations. This is a very thorough one. This I don't know if we'll. I feel like this one might take a little more time for us to just play with it on our own time.
Yeah.
We'll see though.
Welcome back to part 2 of this lecture in creating waypoints and A-star pathfinding. So far we've created a map with a tank, which is our NPC, and a series of waypoints that we've created edges between to construct a graph. We've also added the graph code in, which contains an A-star algorithm, and we'll be able to ask the graph to find us a path between one and another of our waypoints. In the follow path code that is attached to our tank, there's 2 public functions. One is to go to the helipad or go to heli, and the other one is go to ruin, which will take us up to the back of the map where there's a ruined tank there. Each of these runs the A-star algorithm from our current node to a specified position based on where the waypoint is in the waypoint array. Now our job is to call these functions from outside of here and use buttons. So with all that done and ready to go, let's go over
get a little
to
bit of
the
UI.
hierarchy, and we'll just right click, go down to UI and find
Yui.
that's going to create a canvas, a button obviously, which will be
Well,
childed
you
to the
say
canvas,
you say
and this
GUI.
event system. Now this button will appear
I
in the
guess
scene.
that's
If you go to
true.
the 2D view and just zoom out a little bit, we'll find the button, there it is. And it's showing up on the canvas. So this white bit shows you the extremes of what you've got in the game view, which is here. You can see the button there, and the scene itself is down here. If you haven't used the UE system before, just note that the scene itself, the 2D scene and the 3D scene, are not related to each other in this view. So don't think that you need to move the button and stick it over the top of the landscape, because that's just not how it works. This button is on this screen within these dimensions. We're going to move it up into the top corner. So just select the button and click on this rect transform location box, and we want to click the top corner, and we want to hold down the Alt key at the same time and click it again, which will reposition the button into that top corner. Now I don't want that button exactly up in the top corner, so I'm just going to select it and just move it down a little bit like that. So when you look at the game view, it's not jammed right up there, it's right there. Alright, so the other thing we want to do is change the text. Over under the button, if you click down, there's a text element, and this gives us the text showing on the button. This will be go to helipad, and that's what it's going to do when we click on it. Before we can have the button run the code that we want it to, that code needs to exist in the hierarchy somewhere, and currently it doesn't. The follow path code is ready to be attached to our tank. Select your tank, drag and drop the follow path onto it. Now, if you remember, there's a waypoint manager reference that it needs to have so that it can grab hold of all of the waypoints and the graph, etc. So just get your waypoint manager and make sure you connect that up to your tank. With that done, we can now go back to the button, and at the bottom of the button's inspector, there's an on-click area. Now, it might look like this, list is empty. Click on the plus sign, and then we want to select the object that has that code.
This
That's our
looks
tank. So
familiar
the
too.
tank
This looks kind of
down
like
there,
the
and we select the function. So drop down this
what is it called?
box,
The
and you'll see
fucking
that it's got follow path attached to it. Now, in the
the
list that's
volume
just off
thing
the
we set
screen,
up
we can
with
put this in here,
cat-like, but also it kind of looks like the Unreal
follow path,
system.
and then it'll show you whatever it can run that's associated with that follow path code, and you'll find you'll go to heli and go to ruin functions in there. So we can just select that.
Go to
heli.
ruin,
And now
go
when
to
that button is
hell.
clicked, it will run that function on the tank, which is so nice and convenient. And the last thing we need to do before pressing play is make sure that we'll be able to see what's going on in our game scene. So that you can see here that the game is currently not looking where we want it to. So I'm just going to go to the scene and go out of 2D view, find the tank, and then scroll out and just manipulate this around. Just want to be able to see what's going on when we run it, basically. Okay, so there we go. And now we'll select the camera and go game object align with view, so that the game is now looking at the scene where we'll be able to see what's going on. Right, so now press play. Nothing will happen. Notice that waypoints all disappear, and that's because the graph code itself will grab hold of all of those nodes and turn off all of the things that are showing up so that you're not going to see them in the final running of the game. Press the go to heli, and you can see that the tank goes to the first waypoint that it needs to because it's as closest to here, and then it will take the path directly from there to there. And when it gets to the heli, it will stop because it's got nothing else to do from there. Okay, so let's now program to go to the ruins. Process is the same. Grab hold of the button on the canvas and just press Ctrl D, which will create you a duplicate button. Go to the scene and go to the 2D version of the scene. Find that button. Now to select it, just click on this icon here so that you get the little blue dots around it. That'll allow you to resize it and move it. Make sure you're moving the right one. Move that down just underneath it. And while we're there, we're going to change the text to go to ruin. Now,
I
it's
feel like
going
I've
to have
seen
an on-click on
games
each button, so we go
with
up to
this
the button.
exact same
It's got
UI.
the go to heli on it because we
They just used
duplicated
the
it from
built-in
previous
thing and
button.
didn't change
Now
it.
we can just find the
Yeah.
other function, which is go to ruin, and add that in there instead. All right, so now let's press play, and we should be able to go to the helipad, which will take our tank first of all to our current waypoint down to here, at which point it will set that to the current waypoint.
I wonder if she'll implement any sort of fix for that.
And
Like,
stop, and then we go to ruin.
that
Now
seems
it's not going
kind
to
of
take this path
silly.
back up to there because it's much quicker for it to go this way because of the distance that the A star is calculating. And you can see now that it's following the path along. There was a waypoint there. There's a waypoint over here that it has to get to avoid these rocks, and then it will go to the waypoint up there. Okay, great. So that's working. Last thing to try is the point that we had over here where there's only a one-way connection. So we'll duplicate the button for ruin, move it down, and then we'll change the text to go to, I'll call it tanks. They look like big industrial storage tanks or something. That'll do. And for its button, it's going to run a function we haven't written yet. So we need to go back into our follow path code, and we're going to copy one of the go-tos that we had before and paste it underneath. And this time we will go to tanks, and the tanks are at waypoint. They're at waypoint number 9, which is 8 in the array, and we make sure that we set the current waypoint back to 0 before we get going. So save that, switch back into Unity, and then grab hold of that button and set its function for the one we just wrote, which was go to tanks. With all that saved, we're ready to play. So let's begin by going straight to the tank. First of all, it has to go to its current waypoint, which is this first one up here, and then it will follow this path that it has. It can't zip across to here because it has to come back to this one that's down there, which is our intersection. Now it's going to come around and end up down near these storage tanks. At this point, let's say we want to go to the ruin. The shortest distance would be that way, but it can't go back along that path. So let's have a look what happens. It's going to go around because it's found a path that will go around, and then it will come back and join up with that waypoint that's just here to then take the one here and end up over there. So that's the A star algorithm and waypoints, and you can see how powerful it is. It's really quick to calculate distances, and you can use these for navigating around all sorts of different terrain. So
I want to get
With all that,
before she goes
keep
into
going
play mode
underneath.
real quick. I want to get a screenshot of that.
Okay, great. So that's working. Last thing to try is the point that we had over here to avoid the following stop, and then waypoint down and add that in there instead. All right. So now let's press play
Oh damn!
and on and move it. Roll D, which will create.
There we go. Like I guess you can't really see this, huh? I guess that's the end of the video, so I'll switch to my other thing. Let me switch my screen to be just my screen. And then if I bring up Paint, drop that in. So it seems like if your goal is this, like it almost seems like there should be a way to just know that it goes like, or if your goal is over here, it goes there. Like, it seems weird that it has to go there, then there, you know? And I wonder if there would be a way to kind of alter that, to take that into consideration.
Isn't it just going to its closest and then she clicks the button?
Well, it's just calculating the best path to this point, and because of the way, I don't know, just because of the way it works, it calculates the path as this, then this.
Yeah, it's waypoints like I mean, like, the real purpose of waypoints would be like to get around something. So it's kind of a weird positioning here.
Yeah.
But that, like in Far Cry, how I was saying how they had like the auto driving really good.
Yeah.
They called them waypoints, and I get why they called them waypoints now, because it was like you do a waypoint and it has to like calculate around all this stuff.
I feel like it was working really well everywhere else. It was just right there that annoyed me. It was the same thing when the goal was ruins. She went that way, then like that, you know? And it seems like it would make way more sense to just go straight to this one. Like, it seems like it has to hit this node first, no matter what. Which is kind of silly.
Maybe that's intentional.
Yeah, I mean,
But
once... Sorry.
it's kind of like a cargo heli in Rust, how it just flies over the different monuments.
Yeah. I'm sure that's a very similar system. And I'm
Or
sure the
like
paths
the-
between them are like way more open because you could just draw a path like this. It doesn't matter because it'll just fly over everything.
Yeah.
But yeah, this one seems like it'll be fun to play with as well. I'm hoping there's a way to kind of work around that system. I guess the fix would be just move the node to be down here. There's no reason for that waypoint to be up there, but whatever. I guess that waypoint is like almost completely unnecessary. But I guess this at its bigger scale would be just like a fuckload of waypoints, I imagine. Like I feel like you'd have one here, 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 here. Like if you wanted the place to be like actually more explorable, you would just cover the place with a bunch of these things. But I don't know. I wonder if you just have a grid like over the whole map and just delete the ones that are in unattainable areas, kind of that kind of deal. Okay, yeah, again, so we're both gonna maybe, hopefully we'll both play with this a little bit off stream before we come back for the next stream. And then the next stream will just be a little bit of the results of what we got playing with on our own time, as well as some experimentation on stream of just seeing what we can do. And then maybe one more stream after that of the same thing, because this seems like it might get a little more complex than the last one. And then we'll probably move on to the A-star algorithm after that.
Oh, I think you cut out. I thought you like paused really long.
Oh, wait, can you hear me now?
Yeah.
Damn. What was the last thing I said? Do you remember?
It was like in the middle of a sentence, so I was waiting for the next word.
Damn. Okay. Well, hopefully that was just in Discord that I cut out.
Yeah.
But just in case it wasn't, basically all I was saying was, off stream, we're both going to experiment with this a little bit, play with it in our own time, and then we'll meet up for a stream and do the same thing, but like together. We'll play with it, you know, try to make our own version of it. Then we'll do another stream after where we do the same thing, just play with it a little more. And then after that, we'll move on to the A-star algorithm tutorial and just watch that one on stream, talk through it, see what we can do. I think that's the general outline. So yeah, look forward to that if you're watching. And I think that's the stream, yeah.
Yep.
I love that. If only she didn't do that dumb spinning shit, this would look so cool, so much cooler. That's like really satisfying though. Okay, so I guess I'll set up oh, this will actually be pretty interesting because I could set up like node right at the door and then nodes inside of each individual store. And then nodes up on the second floor, I guess. Actually, I don't know about that. We'll see, I guess. I'll experiment with that. That might be a little above. I don't know if we can do elevation yet. We'll find out, though. But yeah, hopefully I'll have a little roaming AI. Maybe I'll make some animations for this guy. On Twitch, I suppose?
On Discord.
Oh, okay. Well, whatever. I mean,
Yeah.
that's the end of the stream.
Good night.
Goodbye.